This is demo 1 of 2 demos that simulate a ride-sharing application. The simulation is contained in a web page using Google Maps for display. The demo attempts to show a real-world application that can be executed in Ritc using rules, no coding required. The demo sequence goes like this. After retrieving the historical rides from Strata, the simulation sends each passenger request with the appropriate delay, slowed down slightly for the demo, to the Ritc rule engine using the Ritc API. Ritc tries to match the request with a nearby driver, not already carrying passengers. Passenger requests are shown as green passenger icons on the map. Ritc returns the result back to the caller, in this case this simulation page, and when there is a match, the passenger icon is removed and replaced with a blue car, which starts moving along its trip route, finally dropping off its passenger. There are 2 rules. The rules can be built in the Ritc Visual Rule Editor using drag and drop on a canvas. Underlying the editor is the Ritc API, by which rules can be created, maintained, and executed. The 2 rules are: rule number 1, receive the driver available notification and store it in the database. That's done outside this demo. Rule number 2, in this demo, only one rule is used to attempt the match, this rule. The rule has 4 triggers, one of which uses the Google Distance Matrix API. So trigger number 1, receive the passenger pickup request. Trigger number 2, using the passenger coordinates sent in the request, it looks for nearby drivers in a driver's database who are available but not already carrying passengers. Trigger number 3, it uses the Google Distance Matrix API to get the actual current distances of each driver and chooses the nearest one. Trigger number 4, at this point the simulation assumes there is a match and sends the start your trip instructions to the driver. As an alternative, it could send a request to accept this ride to the driver, in which case another rule would be needed to process the acceptance. This would probably be required in real life. The rule action is to return the results to the caller. In the video, the passenger request, pickup, and drop-off entries are shown on the right. The time, in milliseconds, that the rule engine takes to attempt and execute the rule is shown in parentheses next to the pickup entries. 463 milliseconds, 606 milliseconds, 620 milliseconds, 998 milliseconds, generally within a second. These are real response times from the Ritc rule engine. At the end of each trip, indicated by the drop-off entry, the blue car is removed from the map. You will see that some passenger requests that are not fulfilled see the green passenger icon still showing near the end. This is because there were no entries in the driver's database that were available as candidates. This was done on purpose to simulate a possible real-life situation. The passenger requests in this simulation are using real New York City 2015 taxi data. The simulation is throwaway, but these same rules could be used in a real application. Just replace the web page simulation with a mobile app that sends passenger pickup requests containing location coordinates, driver availability notifications, and any other messages that would be handled by the rule engine. Ritc listens and responds in real time. This is just one example of the type of application that could be built and run in Ritc.